That says, draw a picture of and describe with at least one sentence dipole-dipole forces between two molecules of, well, you can see one of the homework questions actually says HCl here. I don't think this is on it, but if it is, here's a different example, CH3F. So CH3F is definitely something that has dipole-dipole forces and does not have hydrogen bonding. Let me draw a Lewis structure for this, and drawing Lewis structures is going to be the key, and best Lewis structures even, is going to be the key to understanding IMF. If you draw the Lewis structure, you'll see that the carbon is in the middle with 3 hydrogens and a fluorine. And then because all Lewis structures have all pairs of electrons, we put the electrons in the fluorine there. If you count up all the valence electrons, you'll see that this is correct. You can tell via 2 methods that this is a polar molecule. And polar molecules are molecules that have net dipoles. First off, you can see that around the central atom, there are H's, and then there's something else, which is an F. Anytime there's 2 different things around a central atom, chances are there is a dipole and it is a polar molecule. And then if you wanted to see for sure, you could draw it in its shape. We have a fluorine and 3 hydrogens in the tetrahedral shape. If we draw dipoles on this, we see there's a dipole going straight up towards the fluorine. And there are 3 other much smaller dipoles. You can draw them or you cannot. So, but regardless of what you do, these dipoles, if you draw them, point generally up, and that adds to the dipole here. Sometimes I just skip drawing these CH dipoles, so I'm just going to write OK to skip. Drawing CH dipoles because they never tell us anything. So this is a fine answer for if I were to ask you to draw dipoles on this molecule, or just doing the CF one is also fine. Any questions about that part of it? I know I'm not done yet. If not, then so now I've just established that this is a polar molecule and that this dipole between carbon and fluorine is the most important, if not only dipole in this molecule. So now I'm going to draw a picture of and describe with at least one sentence dipole-dipole forces. And so I'm going to do that down here. I'm going to, actually I'll do it right here. I'm going to draw this again. And then what you want to draw is a second molecule such that in some way the positive part of the dipole on this molecule is close to the negative dipole of the other molecule. And so what you can do is you can put the F here, C, H, 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 oop. And you have dipole alignment. That's one way of looking at dipole-dipole forces. And then you've got the fluorine close to the carbon because the negative portion of this dipole is attracted to the positive portion of the dipole in the neighboring molecule. And then as a sentence, I would say the positive or the negative portion of one dipole is attracted to the positive portion of the dipole on a neighboring molecule. And let me say that again. I think I could use better words. The negative part or pole since it's a dipole, we can call this part a pole of the dipole on one molecule is attracted to the positive part or pole of the dipole on another molecule. I think somebody has their volume on. I can hear something.
Professor, I have a question.
Go ahead, Aziz.
Yeah, does the arrow has like positive and negative side, or because you are talking about the positive side of dipole and the
Yes.
negative side of dipole?
Yeah, so this is a dipole arrow, and a dipole arrow has a plus on one side. That's the positive portion. And
Okay.
it points towards where the electrons are more likely to be. So the bonding electrons right here are more likely to be associated with the fluorine because the fluorine is more electronegative. So does that answer your question, Aziz?
Yeah, it does. Thank you.
Awesome. Yeah, good question. The negative part or pole of the dipole in one molecule is attracted to the positive part or pole of the dipole on another molecule. And I guess typically we say particle and not molecule, but to have a dipole, pretty much, I mean, you have to be at least a molecule, so you can't be an atom. And you won't be an ion either because ions have ion-ion forces. Any other questions about this?